Lesson 39, Algebra 2. This one's a little bit longer. We're going to start off, the first thing we're going to talk about is difference of two squares, and then we're going to do a parallelogram proof and a rhombus proof. So difference of two squares. So let's look at the examples on 39.8. I'm going to write a couple. I'm not going to write all of them. I'll read them though. It talks about conjugate. When we have an algebraic expression, and when they're the same except for the sign of the second term is different, we say it's a conjugate of another expression. So, oops, 2x plus 3y, negative 2x minus 3y. So the first one says negative 2x minus 3y is a conjugate of negative 2x plus 3y, because the second sign of the sign of the second term is opposite. Negative 2x plus 3y is the conjugate of negative 2x minus 3y. And it goes on to say 3x plus 4 is a conjugate of 3x minus 4. And 3x minus 4 is a conjugate of 3x plus 4. Now, when we multiply them, and I'm not going to write it all out, but if you look at the example on your page, you see that when you multiply them and you combine them, the middle term goes away. It simply produces 0. So when we say this, we can see that each of these products of conjugates can be written as differences of squared expressions. So you see they have 2x squared minus 3y squared, or 3x squared minus 4 squared, a squared minus b squared. So they are called differences of squares and can be factors. Not a procedure, you just factor. So let's look at one. So we have 4x squared minus 9 equals 0. So we have a difference of square here. So we can do 2x plus 3 times 2x minus 3. Then you can equal them 0, use the zero theorem, and solve for x. You get 3 halves and negative 3 halves. So let's look at the next one. Solve 81 m squared minus 25 equals 0 by factoring. Well, we've got a difference of squares, so we take the square root of this, which is 9m, plus the square root of that, which is 5, times its conjugate, 9m minus 5, and there's your factoring. Then we simply equal them to 0 using our zero theorem, and we solve for m and get negative 5 nines and positive 5 nines. So that's all factoring of difference of squares. Recognizing what a difference of square is when you have the first factor is a perfect square minus the second factor, which is a perfect square. Alright? So let's move on to our proofs. Let's prove the parallelogram proof. We already talked about the first three. Now we can remember, if you look at, there's some properties that are listed. The sides opposite each other have equal lengths. The angles opposite each other have equal measures, and the sum of the measures of any two consecutive angles is 180 degrees. And then the fourth one says the diagonals bisect each other. So we've already proven in a previous lesson the first three properties. Now we're going to prove that it bisects. So we said a parallelogram. I'm going to attempt to draw this. So we have A, B, C, D, and you've got M, oops. Okay, so these are things that we've already proved. So this, and it's shaded. This is shaded, and this is shaded. It says the small shaded angles B and D, so these angles have equal measures because they are alternative interior angles. Remember, these are parallel. This is the transversal line. They're alternative interior angles. So because of that, they're equal. We've already proved them. And we say the vertical angles marked at the intersection of diagonals are equal. So these are equal. Thus the third angle in each triangle are equal, and the triangles are similar by AAA, meaning that's what a similar triangle means. The scale factor is 1 because the corresponding long side are equal. So therefore, they must be congruent triangles by AAAS. So therefore we can say triangle CMD is congruent to AMB. So side CM is equal to side MA because corresponding parts of corresponding congruent triangles are congruent, meaning they're the same. So these two are corresponding. So therefore they're equal. Just like DM is equal to MB. Alrighty. So this proves that the diagonals of a parallelogram bisect each other. So let's move on to a rhombus. Okay, rhombus is a parallelogram that has three additional properties. The first is a definition, which we know. So the rhombus is a parallelogram whose four sides have equal length. The other two are theorems and properties that we can prove. So the second one says the diagonals of rhombus bisect the angles of the rhombus. Remember, a bisect means cut something in half. 3 says the diagonals of a rhombus are perpendicular bisectors of each other. So let's prove the first one. Okay, so you have B, C, A, D. 1, 2, 3, 4. Okay, since A, B, C, D is a rhombus, AB, side AB is congruent to BC. We also know that in a triangle, angles opposite sides of equal lengths have equal measures. So, because these are equal, then their corresponding angles are also equal. So these two angles are equal. Okay? So therefore angle 1 and angle 3 are equal. But because the rhombus is a parallelogram, side BC is parallel to side AD, and AB is parallel to side BC. Therefore angle 2 and angle 3 are equal because they're alternative interior angles. Okay? Because of the transversal line that bisects these two parallel lines over here. Okay? We also know that angle 1 is equal to angle 4 because they are also alternative interior angles. Therefore, angle 1 is equal to angle 3, and angle 2 is equal to angle 3, and angle 1 is equal to angle 3, and angle 1 is equal to angle 4. By the sixth postulate of Euclid, we know that things equal to the same thing are equal to each other. So thus, angle 1, 2, 3, and 4 are all equal. Therefore, AC bisects angle A and angle C. We can also show that the diagonal BD bisects angle BD in the same way. So we can go back and prove that this bisects it in the same way. Alrighty? Because all these angles are equal, this bisects it right in half. So now let's do the next one. Let's show that these two bisect each other and form right angles. Remember, if you have one, then they're all four right angles. You can't have one without the others being right. So let's remember, if this is x degrees, we know if we had a regular triangle that angle A, this whole thing, and angle B together have to equal 180 degrees because it's a quadrilateral, a parallelogram, right? And we learned that angles next to each other the sum have to equal 180 degrees. We proved that on a parallelogram. It is a parallelogram. It just has to be, it's a parallelogram with equal sides. So if we know A plus B has the whole thing is equal to 100, or D has to equal to 180 degrees. I'm going to change this A, B, C, and change this to D. I've written wrong. So therefore we know that this is right here, we don't know, is x degrees, and we know that these two are going to be A degrees over 2 and B degrees over 2. In the rhombus on the right, we see that the base of the angle triangle measures half of angle A and half of B. Since A plus B equals 180, half of the sums equal 90. So regardless, half of the sums are still going to equal 90 degrees. So if this plus this equals 90 degrees, and you add it to x, it has to equal to 180 degrees. Therefore, x is 90 degrees. Therefore, this is 90 degrees, this is 90 degrees, and this is 90 degrees. So now this proves the diagonals of a rhombus are perpendicular bisectors of each other. So let's do one example. Example 39.3. It says, in this rhombus, the measure of the reflex angle is 280 degrees. Find A, X, B, K, and C. Thus the sum of 280, X, and A equals 360. Right? You see how it goes? I'll try and draw this. So we're saying from here to here is 280 degrees. So therefore, X plus A plus 280 has to equal 360 degrees. Thus, X plus A must equal 80 degrees. So we get X plus A equals 80 degrees. Angle X and angle A have the same measure because DF bisects angle D. So, can't we just say X is 40 and A is 40? We take this and divide them in half because they're equal. Because this bisects, so these two are equal. Alright. The sum of adjacent angles in a parallelogram is 180 degrees. So, K plus B has to equal to 100 degrees. Right? If this is K plus B, because this angle plus these two angles, which equal 80, have to equal 180. So these two have to equal to 150. So K plus B has to equal to 100 degrees. But EG bisects angle G, so K and B are equal. So K is equal to 50, and B is equal to 50. Now can we find C? Because it's a rhombus, and we said the two lines that bisect it form 90-degree angles here. So C is 90 degrees. So you're just using your theorems to solve for these degrees. Alrighty? Do your homework, do your practice problems, and we'll see you in class.